Good evening friends, this is Celesta Matthews from Karuna University, and today I am going to show you a program that is based upon binary search tree, where I will be inserting into the tree as well as I will be displaying the in order, pre-order and the post order. Now what actually is a binary search tree? The binary search tree has some properties. Now what are the properties? The first thing is that there should be a maximum of 2 children. That means each and every node in the tree must have 2 children. It can either have 1 children also, or it can have none children. The nodes which have no other children are called leaf nodes, and the first node is called the root node. Now the other thing is that in the binary search tree, all the elements to the left of the root are less than the root element, and all the elements to the right of the root are greater than the root element. So now we'll see how to implement it. First of all, each and every node is a linked list. So each and every node is connected. So what I have done is I have created a structure called node, and I have made 3 members inside that. First one is the L pointer, and second one is the R pointer, that is the left and the right pointer. These will be pointing towards the left child and the right child. And the third one is the data, which stores the element in the node. Now we'll move on to the main method first. Okay, here in the main method, the variable choice is used to say what and all input the user gives after displaying the menu. And here the char CH that actually has the character n. Now this is used to iterate my do while loop. The other one, what I'm doing is I'm creating a root node over here, which will be pointing towards the root node, and I have made the root node to null. That means for now the binary search tree is not at all created, so the root is not pointing to anywhere. Now in the do while loop, what do? I display the menu first, that is 1 is to insert node, second for in order, third for pre-order, and fourth for post order. Now I put it into the switch case, and the first one is my insert node. So here is the code. First what I do is I create a temporary node, and I ask the user to enter the element, and I store it into temp arrow data. Now temp arrow left pointer is equal to null, and right pointer also is equal to null. Now first what I have to check is that if a binary tree already exists or not. If it does not exist, first of all I need to create a root. So I'm checking if root equal to null. This means that there is no binary search tree at present. So I make the root point towards the temp, that is the new variable. Next what I do is that if this condition is false, that means a root node already exists. Then what I do is I call the function BST, that is the binary search tree, and I pass root and temp to it. I iterate it, I ask the user if he wants to continue or not, and I put it into the while loop. Now we'll see what is there in binary search tree, that is the BST function. So here it is. I'm passing the root and I'm saving it into PTR, and the temp is stored into temp. Now first of all what I do is, if temp arrow data is less than or equal to pointer arrow data. Now first of all I mentioned the property, that means that is all the elements less than the root are to the left and greater than the root are to the right. What if they are equal to the root? So here what I have done is all the elements equal to the root also I have put it to the left. You can either choose it to put to the left or to the right. If it is to the left, then I check that if the left pointer of that particular node is empty or not. If it is empty, I can insert the node over there. If it is not empty, then I need to make it a recursive function. So I'm checking over here, if pointer arrow L PTR is equal to null, then PTR arrow L pointer is equal to 10. That is, I'm inserting this node. Otherwise, I again call the function, that is I'm making it recursive, and I pass PTR arrow left pointer to PTR and temp to the same value temp. Otherwise, that means if the value is greater than the root node, then I do the same thing, except that instead of left pointer I make right pointer over here. Rest all the function is the same. Now again back to the main menu. Here in case 2, that is for in order, 3 is for pre-order and 4 is for post-order. To each and every function I pass root to it. Okay, so now I'll tell you what in order, pre-order and post-order actually means. In order, in the sense, first you have to go to the left node, then you have to print the data, and then you have to go to the right node. That means in order, in the sense data lies at the center. Pre-order means data will come first, then the left node, then the right node. And post-order means first the left node, then right node, and then the data. So in the in order function, I have passed the root to it. Now I am checking if root equal to null, then return 0. This means that there is nothing in the binary search tree. Otherwise, what I do is I again call the in order function and pass the left pointer to it. Then I print the data, and then I print the right pointer to it. So this is actually the recursive function. The same is done in the pre-order, only the order is changed. That is, first data comes, then pre-order, then left pointer, and then the right pointer. And in post-order, first the left pointer, then right pointer, and then the data is printed. So this was all in the program. Now we'll see how it executes. Okay, so I have the menu over here. First I'll press. Okay, so first I need to insert into the node. That means I need to create a binary search tree. So I pressed 1. I enter the element such as 5. Okay, I want to continue. Yes. Element is 3. That means it goes to the left node. Okay. Now I enter 7. It will go to the right node. Okay, yes. And then I'll press 1. Which will again go to the left node. Now I press no. Okay. Now I have the insert node, in order, pre-order, and post-order. Okay, first I'll display the in order. See, this is the in order sequence, that is 1, 3, 5, and 7. So we all know that if we have in order, all the elements are printed in the increasing order, that is 1, 3, 5, and 7. You can check it over here. Now I'll display the pre-order. Pre-order is for 3. See, this is 3, okay, 5, 3, 1, and 7. I'll display the post order. That is 1, 3, 7, and 5. So this is how my program works. Hope it helps you. Thank you.